So like I was saying, we're drawing this position vector OA. How do I know it's a position vector? Well, you see that capital O there? It means I'm starting from the origin. So from the origin to the point A. And it told me in this case that this position vector is represented by the column vector 2, 3. So what does that mean? From my starting point, which is the origin, I would go 2 spaces to the right. How do I know this is to the right? Well, the top number, remember the column vector is always in the form X, Y. So whatever number on top tells me about the movement along the x-axis. The number to the bottom tells me about the movement along the y. So because there's a positive 2 on top here, it tells me 2 spaces to the right. So from my starting point, which is this origin here, I'm moving 2 spaces to the right, and then the bottom number, which tells me about the movement along the y-axis, because it's a positive number, means that I'm moving 3 spaces up. So what's going on? From my origin here, moving 2 spaces to the right, so let's say this is 1, this is 2. And then from this point here, I'm moving 3 spaces up. So 1, 2, 3. Therefore, my point, after moving 1, 2 spaces to the right and 1, 2, 3 spaces up, this point right here would be my point A. So because this is a position vector, I had to start from the origin. Unlike just now, like before when I was doing the vector AB, I started at any point I wanted to. Why? Because it's not a position vector. How do I know it's not a position vector? Because I didn't see that capital O, right? The vector AB meant that I was starting from a point A and going to a point B. So I started anywhere. This is the position vector. I'm starting from the origin. I must start from the origin, and then I go to whatever point. In this case, the column vector was 2, 3. So what does that mean? From my starting point, which is the origin, I need to move 2 spaces to the right. So I move 1, 2 spaces to the right. But then I have to move 3 spaces up. So from here, I went 1, 2, 3 spaces up. And therefore, this right here, this point is my point A. So you can then draw your arrow to represent your vector. And don't forget the direction, because a vector is both magnitude and direction. So you need to draw the length of this line as well as the direction it's going in. So it's going from O to A, and therefore my arrow goes that way. Do you understand now, Kitania?
Yes, Miss. Thank you.
No problem. Good. Next. So can I clear this off now? Yes? No?
Yes, Miss.
All right. Okay, so just a little note that would help you when you have to do questions. A question might involve this, like require you to know this. See that position vector? So we drew the position vector for OA, right? You see that column vector that they gave me? So in this case, it's 2, 5, right? That's actually the coordinates of the point A. Let me just show you that real quick. So the position vector tells us the coordinates of the point. So let me do that example just now. So say I have the position vector OA. Don't forget the arrow. And they told me that this is represented by the column vector 2, 5. Remember, this is a position vector, so I must start at the origin, and then I'm going to that point A. Okay, so I have my Cartesian plane. Let me just use one. Cartesian plane, my X and my Y. I have my scale. So this is 1, 2. Let me not do this here. Position vector. So I must start at the origin. That's what that capital O means, right? Starting at the origin, going to the point A. So origin, right hand. My column vector is 2, 5. So what does that mean? Remember, the column vector is in this form. So because this is a positive number, that means from my starting point, which is the origin, I need to move 2 spaces to the right. So 1, 2 spaces to the right, and then the bottom number, which tells me about the movement along the y-axis, is a positive number, right? So that means 5 spaces up. 1, 2, 3, 4, 5. So I'm going 2 spaces to the right, 1, 2, and then from this point, I'm going 5 spaces up. 1, 2, 3, 4, 5. So this right here is my point A. So you would draw your line, draw your arrow, whatever, right? The position vector, so this 2, 5, actually helps me to find the coordinates of the point A. If I wanted to find the coordinates of the point A, I would say that the x value is 2, okay, and then the y value is 5. Therefore, the coordinates of this point right here is 2, 5. Do you understand that? Yes? No? The position vector OA actually helped me to find the coordinates of the point A. They told me that the column vector is 2, 5, and therefore the coordinates of the point A has to be 2, 5 as well. Yes, you understand. Okay. And now let me show you why. So remember, this works only for the position vector, right? The position vector, whatever the column vector that they gave you, whatever is the column vector, that's the coordinate. So in this case, the position vector is 2, 5, right? Well, the coordinate, the column vector that they gave you for the position vector OA was 2, 5. So what does that mean to me? The coordinates of the point A has to be 2, 5 as well. But it does not work if the vector is not a position vector. And let me show you. So I'm erasing this, and keeping my Cartesian plane though. Let's say this is not a position vector now. Let's go back to the AB. AB, we said it's not a position vector. So I don't necessarily have to start at the origin. I could start at any place on this plane. So if I decided, okay, I want to start my point right here. So this is A. And then from my starting point, I applied this, right? So 2 to the right, 5 up. I use a different color. From my starting point, I'm going 2 to the right and 5 up. So 1, 2 to the right, and 1, 2, 3, 4, 5 up. So about right here. Yeah, right. Bro. Right here. Okay, you get what I mean, right? So this is my point B. Hold on, people are joining. So then you would draw your line, okay, yeah, whatever. Yep. Oh my. Let's just pretend that's a straight line, okay? So let me try that a little bit. So around right here. And then I'm lining up with this. Okay. And then this is my line. If I ask you to find the coordinates of A, you would tell me, okay, that's easy. Look, it's 2 on the X, and then it's minus 2 on the Y. So the coordinates of A is 2 minus 2. But that's because I decided that I wanted to start at that point. What if somebody else decided they wanted to start at 1 minus 3 or minus 7, 2? So You understand what I'm saying, right? You cannot, just look at this position. I mean, my column vector is 2, 5, and decide, okay, my point A has to be the coordinate 2, 5, or my point B has the coordinate 2, 5, because that's not true. For free vectors, the person, can decide to start at any point on this Cartesian plane. So the coordinates of my point, it's not necessarily 2, 5. Do you understand that? Okay. Can I have one more person answer me? Do you understand why the position vector, I can use this as the coordinates for my point, but if it's a free vector, I can't do that? I can't assume that? Different people choose different positions. Yeah. For free vectors, the person can decide to choose any point on that plane. So it's not necessarily 2, 5. However, for position vectors, I must start at the origin. So therefore, this would always be my coordinate for the point. So let's say free vectors, it's subjective, but then position vectors is objective. So free vectors, I choose what I want to do. Position vectors, you must stick to that way. Stay at the origin. Start from the origin. You have to do that. But for free vectors, I don't have to do anything. I can start wherever I want to. Okay, so I'm moving on since nobody else is responding to me. Can I clear this off? Right. So that's what I have right here. A position vector helps us define. What?
How do you get the PowerPoints? These PowerPoints.
I always post them when we finish with the topic.
Oh, okay. So
Yeah. All right. So that's what I have here, right? A position vector helps us define the coordinates of that point. So if I have my position vector OA, and it told me the column vector for this is 2, 5, that means that the coordinates of the point A is 2, 5. It would always be this way for all position vectors. So let's say I had a position vector OA, I still have OA, but then the column vector they told me was 1, 3. What does that mean? The coordinates of my point A is 1, 3. If I had a position vector OC and they told me the column vector was 1, 1, then the coordinates for the point C would also be 1, 1. It always works that way, right? Okay, finding magnitude of a vector. We said a vector has both direction and magnitude. Magnitude meaning the size. How exactly do we find the magnitude of this vector? I mean, if you have it on a Cartesian plane, actually no, let me not go into that. Right. Find the magnitude of a vector. So you need to know that the magnitude of a vector is also referred to as the size of the vector. You might see the length of the vector or modulus of the vector. You can see any of these terms on the exam, right? They might ask you to find the magnitude of the vector, whatever, the size of the vector, whatever, length, modulus, and you need to know that this is what they're talking about, right? You can measure the distance of the arm on the Cartesian plane to find. Yeah, that's what I was gonna say. Right. So what is right? Okay. Right. X plus y? No, it will be x. Okay, I'll show you that just now, right? If okay. So how exactly do you find the magnitude of a vector? I'll show you why it's not x plus y, right? The magnitude of a vector is denoted by this, right? So you would see like these two lines here, and then the vector in the middle. So what exactly do I mean by that? Let's say given a vector v. So I have the bold right here, right? Because I'm typing, so I bold the letter, right? So say you're given a vector v, then if they ask me to find the magnitude of this vector, then you put two lines, and then you put the symbol for the vector in the center, right? That's what this is trying to show you. So whenever you see something like this, you know they're talking about the magnitude of the vector. Let's say your vector was OB. You would see it like this. So this is the vector OB. But if they want you to find the magnitude of this vector, you would see the two lines next to it. That's how you know they're asking you for magnitude. How exactly do you find the magnitude? Well, it's the square root of x squared plus y squared. How exactly did I get that? You might be wondering. Let's go back to the blank screen. Say I had my Cartesian plane, right? I'm not going to draw it out. But let's say I had my Cartesian plane. This was my starting point. This was my ending point. So what vector? Let me say AB, right? I'm just sticking with the AB. And I found out that this is what it looks like. Going from A to B, whatever points those are, right? We know from what we just practiced, this right here, this displacement right here would be along my x. So vector AB, column vector is always x, y. Okay, let's just pretend that looks neat. My column vector AB is denoted by xy. X is the displacement along the x-axis, so it would be this right here. And then y is the displacement along the y-axis, so it would be like this. Whatever my x value is, whatever my y value is. That's how I went from A to B. Notice, well, this one is supposed to be straight, right? This would actually give me a right angle triangle. We know from our geometry, coordinate geometry, if I'm given a right angle triangle and I have two sides of that triangle, so this would be the base, and let's say this is the height, right? We know if you're given two sides and you want to find the third side of the triangle, we apply Pythagoras' theorem. What does Pythagoras' theorem state? The hypotenuse squared, so let me just put h squared is equal to this side plus this, well, the square of this side plus this side. So usually you might see it like a squared plus b squared, or sometimes you see a squared plus b squared is equal to c squared. You might see c squared is equal to a squared plus b squared. It doesn't matter, right? They're just letters. Just know this first one represents the hypotenuse, and then the other two is the other two sides of the triangle. In this case, if I want to find the magnitude of the vector, which is this length here, this would be my hypotenuse. So the length I'm really trying to find is the hypotenuse. A, in this case, I'll just say A is x, B is y. Therefore, the magnitude of this vector, so what I'm trying to find, the magnitude of the vector squared, so let me just put a squared thing here, is going to be equal to x squared plus y squared. So whatever my x value is squared plus whatever my y value is squared. But so if I want to find the magnitude, this right now is the magnitude squared. If I want to find the magnitude, we know that we need to square root both sides. So I will end up with the magnitude of the vector AB. So I'm not writing that again, right? Let me just put m for magnitude, would give me the square root of whatever my x value is squared plus whatever my y value is squared. Do you understand that? Yes.
Yes, miss.
Okay. Cool. Now to show Josh why triangle, yes, called trigonometry, triangle stuff. Yeah. So let me show you, Josh, why this is not the same as this value plus this value. So I'm choosing some random numbers, right? They asked me to find the modulus or magnitude of the vector. This side, I'm going to use the formula that I just showed you. The magnitude is equal to the square root of a squared and e squared, x squared plus y squared. And on this side, we're going to check x plus y. So let's say they told me x is, let me just stick with the 2, 5, right? So x is 2, y is 5. That's the column vector they told me, right? So my x value is 2, my y value is 5. And they asked me to find the length of this, or the magnitude of the vector, also known as the modulus, or the size. That's what they asked me to find, right? So Josh was asking me, why can't it be x plus y? So let's test that out, right? We're trying to find the modulus, magnitude, same. So we're doing x plus y. That would be 2 plus 5. So this is telling me that this length is going to be 7. Okay, so that's using x plus y, right? If I use the formula I just showed you, so the magnitude would be equal to the square root of 2 squared plus 5 squared. This is going to be equal to 2 squared is 4 plus 5 squared is 25. 5 plus 25 is going to give me 29. So using Pythagoras' theorem, which would be more accurate, tells me that the length or the modulus or the magnitude of my vector is root 29 units. So that would be the unit, right? It would be unit. But then using this, it tells me that it's 7 units, which isn't correct. So this is just to prove to you why just saying x plus y isn't right. You actually have to use Pythagoras' theorem to find the length, which would be root 29 units. No, this is a living environment. We're here to learn. Don't say that. It's good when you ask questions. Everybody good with this? Yes? No? Can I clear this now? Why is only one person responding? Okay, I'm clearing this thing. Alright, so that was just to prove to you how we find the magnitude of a vector. So now it's time for you to try it. Can you find the magnitude of these two vectors for me, please? And let me know what your answer is. But yeah, release has the answer. Okay. So if they ask me to find the magnitude of the vector A, all you need to do, follow the formula, right? Is the square root of x squared plus y squared. X is always the top number, y is the bottom number. So if I want to find the magnitude of this vector, I would apply this formula. Well, yeah, the formula. So square root x, which is always the top number, in this case is 2. So that's 2 squared plus y, which is always the bottom number, 3. 3 squared. 3 squared, which is going to give me the square root of 4 plus 9, and 4 plus 9 is 13. So this is root 13 units. Josh, what did you do? Or what did you do to get 30? Oh my, cubed? Oh, okay. So just making sure it's not that you
Yes, I
don't.
think sometimes using the calculator, like I used to get this problem too. I think you put in the brackets. So when you put in the square root, you put the powers, well, the 2 to the power 2 in brackets plus 3 to the power 2 in brackets. Sometimes it does be a bit funny, right? If you're just putting it in a calculator. Well, for more complex numbers. So.
Mhm. Okay. Just making sure it's not that you don't understand. That was just, silly mistake. Because you put cubes instead of square. But yeah, you're right about the putting it into a calculator can be a little tricky. All mental, I'm sharing this because yeah, you could actually do this mentally. It's not that taxing. What's 2 squared plus 3 squared is 13. So square root of 13. 1 squared plus 7 squared is 49, and then 1 squared is 1. So that's the root of 50. Not very taxing. You could do this mentally. But of course, don't do that in the exam. You have to write it out. How else are you supposed to get the marks? So 1 is my x. So that's 1 squared. Plus 7 is my y. So that's 7 squared. Like I was saying just now, 1 squared is 1 and 7 squared is 49. And therefore, 1 plus 49 is going to give me root 50 units, of course. Don't forget units. Units. Or if you wanted to be a little fancy and write this in third form, well, actually that is a third. But if you want to simplify it even more, we know 50 is the same as 25 by 2. So if I wanted to simplify this even more, my answer would be 5 root 2. Oh my. 5 root 2. If they actually ask you to simplify as far as possible, or something like that, you have to put the 5 root 2 in. Like you can't just decide, okay, I'm going to leave it as root 50. If they ask you to simplify as far as possible, this is the answer. 5 root 2 units. I don't think I've ever seen a question where they ask you to simplify as far as possible. So if they don't ask you that, this is acceptable. Root 50, move on with life. Doing that fancy method, no. Okay, can I clear this off now? Yes? No.
Yeah, you can clear it off.
Okay.
Yes, miss.
Thank you. Okay. All right, now that we practiced that, remember vector, the definition of a vector, like basic definition, foundation, vectors, magnitude, and direction. We just learned how to find magnitude, but how do you find the direction? This is how you do it. So the direction of a vector can be calculated by finding the angle that it makes with the x-axis. So it would always be tan theta is equal to the y value and the x value. How exactly did they come up with that? Say I have a vector. So we're going back to the A and B, right? Let's just stick with A and B. This is my point A. This is my point B. Oh. This thing is bro. My point A, my point B. So like I said, we're sticking with this AB thing, right? We're going from A to B. So when I draw this, we know that this displacement right here represents my X, and then this is my Y, right? This is X, and this is Y. So this is my X, and this is my Y. I said we want to find the direction of this vector. And how do we do that? When we calculate in the direction, it's always the angle that the vector makes with the x-axis. So what angle will that be in this case? Well, it will be this angle right here. The angle between my vector, which is the orange, and my x, which is this horizontal line here. Let me just put it in red. This is the angle made by the vector and this horizontal line. This would be my x-axis. That's the value that we're trying to find, the value of the angle that we're trying to find, theta. And that's why, if I'm trying to find theta, this is a right angle triangle, right? So we know if I want to find the angle, I would use my trig function. Which trig function would I use though? I have my opposite side and I have the adjacent side. Therefore, I'm going to use tan. Tan of theta is opposite on adjacent, so opposite is y, adjacent is x. And therefore, when you're trying to find the direction of a vector, it would always be tan theta is equal to my y value divided by my x value. SOHCAHTOA, yeah. Do you understand that? Yes? No? Yes, actually. Right. So it's always the angle between the x, so the horizontal line, and the vector. That's the angle we're trying to find, and it would always be tan. Tan theta is equal to my y and my x. So let's say they gave you the vector A, and they ask you to find the direction of this vector. So we just found the magnitude, this was the first one, right? We just found the magnitude of the vector, and we said it was √13 units. So that's the magnitude. What if they ask me to find the direction? Then I apply this. If A is equal to 2, 2, 3, I'm trying to find the direction. So I'm using this formula here. Tan theta is equal to y and x. Remember, y is always the bottom number, so it will be 3 divided by x, which is my top number, 2. So tan theta is equal to 3 on 2. Remember, whenever you're finding the angles, you always have to use the inverse of the trig function. So theta is going to be tan inverse of 3 on 2. And when you put this into a calculator, it will be 56.3 degrees. Note that the angle is always in degrees. So make sure that your calculator is in the degrees mode and not in radians. Okay? I would love to do so many questions, just me. But we don't have the time. If we want to finish, we can't do that. Okay, everybody understands this, right? Really? 1 minute? Oh gosh. Okay, rejoin.